Now, I want to talk about the J coupling that comes about using this angular momentum analogy. And unfortunately, it's not a clean analogy. I actually had to make this video twice. So let's go back to treating nuclear spin as our spinning top. And we have our spin 1/2 nucleus sitting in a strong magnetic field, and it can be aligned two ways, up or down. But both are stable in the magnetic field, and when we actually conduct the experiment, we tilt them at 90 degrees to each other. So this is a 90-degree pulse, and they begin to rotate. So where does J coupling come in this? And this is actually going to kind of be where this analogy of the spinning top doesn't really help us that much, at least not as much as like the magnet analogy work, but we'll try to make it work out. So what happens is we have this clockwise and counterclockwise rotation, and they do feel each other's spins. This is where J coupling comes from. So if we have two nuclei and they have angular momentums that are pointing in the same direction, they're going to interact with each other differently than two nuclei that have their angular momentum in the opposite direction. So this is where your origin of J coupling is going to come from, is that because you have a random distribution of ups and downs, one nucleus spinning one direction will interact differently with the nuclei that are spinning in different directions. And we're going to have a distribution. Again, because we're working with this angular momentum analogy, they can be spin up or spin down in the magnetic field, so clockwise or counterclockwise. And when we tilt them 90 degrees, they randomly distribute. So take your typical analogy, which is J coupling comes from the magnets being pointed both up, and then a simple example of J coupling, you have one nucleus, there's a chance it'll interact with a spin up and a spin down. Instead of saying spin, we have rotation. So you have one nucleus, it has, for sake of argument, a clockwise rotation, and it has a 50-50 chance of interacting with a nucleus that's spinning clockwise and counterclockwise. And because there is a difference in how them spinning in the same direction versus them spinning in opposite direction that happens, that's where your J coupling is going to come from. And everything else will kind of fall out from there.